This discussion we're having, these are the implications from the Reuben Huberman podcast that were in between the words. This is the stuff that you really want to know. Okay?
Welcome to the Quantum-Based Podcast. Join me to discover how quantum biology reshapes science and healthcare with insights from leading experts and top scientists. Enhance your mind, body and mitochondria with a modern scientific and spiritual approach to optimal health and performance. So let's get quantum-based and discover how light, water, magnetism, deuterium, plasma and charge can transform your life. Hello and welcome. I'm Sarah, and in this episode, I talked to neurosurgeon Dr. Jack Kruse. Dr. Kruse is also an expert in biophysics, especially light, water, magnetism, mitochondria, and how quantum biology works in mammals and humans. In this podcast, we jump around into lots of different facets of science, and I've listed the topics that we discuss in the description, as well as key take-home points. Dr. Kruse and I also mention a lot of scientists, and I put their books, publications, website, videos in the description for you so that you can keep up with this story and understand why Jack is delivering such an important message in this podcast. I've also included Jack's banned TED talk for anybody who's interested. For those of you who are new to Dr. Kruse and his work, I've put his EpiPaleo-RX book, which was published over 20 years ago, and his leptin prescription, which explains how he lost over 150 pounds. So for new people, that's a good place to start. Just to give a very quick overview, Dr. Kruse starts by talking about communication other than nerves and the nervous system in the brain. This is because I asked, is precognition, prophecy and deja vu real in people who suffer from temporal lobe epilepsy? And was one of the greatest science fiction writers ever, Philip K. Dick, actually able to see into the future or maybe even the distant past? So basically, do humans have superpowers? In order to answer this properly, Jack takes us on a journey of how light sculpts biology and explains the next part of the POMC melanocortin story. And this begins with how the nutrient sensor human mTOR really works. mTOR is of great interest to cancer researchers, biohackers, anti-aging scientists, and those interested in sports performance. And Dr. Kruse drops the bombshell about UV light, calorie restriction, and mTOR. Dr. Kruse talks about, in order to power our quantum computer of a brain, we need huge amounts of power, and a human could hold up to trillions of millivolts. So where do we hold that? Dr. Kruse also explains we can generate light brighter than the sun inside our own bodies. And this is why melanin is even more amazing than we thought. And quantum mechanics for certain does happen in a warm, wet body. Dr. Kruse loves paradoxes, and even he gets flummoxed sometimes. And his go-to is E equals mc squared, also Noether's theorem. And Noether's theorem is something that biologists hardly ever consider. And now he's going to bring it to you gently to explain how understanding this is the key to moving to the next level of the story, because he's got more to come beyond this podcast. We circle back to why leading anti-aging scientists are misleading, and the solution is hiding in plain sight in the mitochondria. Another vital part of biology that's misunderstood is inflammation. And Dr. Kruse talks about how to switch from inflammation to regeneration via POMC in the immune system, which comes back to Roberto Becker's work. After an hour in and armed with new knowledge on POMC, melanin and semiconductors, I asked Dr. Kruse about subjects such as telepathy and Rupert Sheldrake's work, what is bipolar, depression, autism. We talk about psychedelics, magnetism and dreams, and a lot more. So you're basically getting all the science, and you'll see here that we didn't have any private conversations without you, and we basically just go straight in. So I'll hand you over now. Hi, Dr. Kruse. How are you?
Great. Awesome.
Thank you very much for taking the time to do this with me.
No problem. I'm just glad I don't have to wear headphones. I was concerned, since you were doing Zoom, that I was going to have to wear them, and I hate wearing them.
Oh, yes, I know. They're like the worst thing ever for the brain. But as long as they can hear what you say, I think it'll be fine.
No, I agree with you. I wish some other podcasters would actually take the head out of their ass, too, and realize that the audio quality, I don't think, is really the main thing. It's actually what we're saying that's the most important part of the message.
But I only had one personal question for you, and it was, do you know anything about temporal lobe epilepsy?
Oh, yeah, a lot about it. I mean, used to do a lot of temporal lobe resections and removal of hippocampus, and mesial portions of the temporal lobe. I mean, that's a big focus in epilepsy surgery. I don't do a lot of epilepsy surgery anymore. It was something I did younger in my life. But believe it or not, it did come up in the Huberman podcast. If you remember, I posted, you heard him say, I posted a pretty provocative paper about apoptic transmission and how when we do subpial resections to do temporal lobe epilepsy cases, that it doesn't work for everybody because there's still communication via light and water that Montagnier exposed. And the reason that guys like Huberman don't really understand this is because Montagnier's papers were stolen by the retards in alternative health to try to prove stuff about water dilution. And that got everybody's focus in centralized science off to what's going on. I was happy to know that Huberman did know about apoptic transmission and that there's other pathways besides wiring, meaning tract or tractotomy, or, action potential science tied to, the biochemistry and physiology that is well known in neurobiology. But this opens up another world if you understand that there's another transmission mode that we use, and that story is actually probably the single most important part of information and energy transfer, and especially in all living things, but really, really important in mammals. Then you begin to understand why I get so angry with a lot of the people I get angry with. It's amazing to me this stuff can be published in the literature and nobody reads it.
Oh, definitely. But there's also certain papers that people hail as the gospel, which have got flaws in them, and there's so many of them. And the thing about the temporal lobe epilepsy was, with the Philip K. Dick and people like Anthony Peake that say they get precognition, and Prophet Muhammad had temporal lobe epilepsy. All I wanted to ask was, do you think that there's actually any truth in that about the?
Yes. There's no question there's truth in it.
Yeah,
I've known that for a long time. Do I believe? I try to explain to people, I think, in the Huberman podcast, but I think it may have hit the cutting floor. Just think about the three mammals that have highly encephalized: dolphins, whales, and us. The interesting thing is, if you understand the evolutionary history of a whale used to be like a horse on land, then it evolved, de-evolved through regression, to go back into the ocean, become the biggest mammal on the planet, but yet it's got the most melanin in its hearing system, and it doesn't communicate the way we do. It does it by echolocation, and it's probably even more complex than it is in bats. And you see that expansion in them. The way in which we communicate is used, like Eddie Chang, the guy that's mentioned in Huberman's podcast. Like, Huberman did his own podcast with Eddie Chang. They grew up together. He's not trying to figure out, how to allow humans to communicate who lose the ability to speak, without words. In other words, he's doing the same thing that you're asking me about. Does a human have the ability built into it to do some of the things that other mammals can do? My belief is yes, but we have evolved a certain way. Whales have evolved a certain way. Dolphins have evolved a certain way because of the light that's in our environment. That's actually what dictated the transgenerational epigenetics. The key question for the people that have these abilities that are out there, what I'm interested in is not their abilities. I'm interested in the environment that they were in before they gained those abilities.
Yes. Are you familiar with somebody called T.S. Wiley, who had a brain infection and all of a sudden became some kind of polymath? And she was talking about circadian biology in 2000. And It's about hormones and stuff like that. And I think, again, exactly what you said, it's sort of back to this question: can a traumatic brain injury? I know it was in the Huberman podcast, unlock these magical abilities, and I was just wondering what your thoughts are on them a bit more, just because you're probably the only person on the planet who has got a theory that I believe.
Yeah, well, I would tell you that I think, if I'm not mistaken, I don't know if I said this in the Huberman podcast and it hit the deck, or it was in a podcast that I've done recently since the Huberman podcast. I told people about a TBI case that I had when I was back in Nashville. This is a long time ago, probably 15, 20 years ago, where a guy got hit in the head and he had no ability to play any musical instruments. After he got the TBI, he actually was able to play the piano like Mozart. It was absolutely stunning. The other time that I've seen it in my neurosurgery career, again, it was a TBI from a car accident. I think this one, if I'm not mistaken, it was in my transition between Nashville and going to Mississippi, but the person wound up getting the ability to speak a foreign language.
Mm.
So yeah, I think it's possible. Do I think centralized science has the answers? The answer is no, but are the clues already published in the literature? That was kind of like the seeds that I gave to Huberman. I said, look, I think the thing I really liked about him after the interview is I realized he does have a much more open mind than I thought beforehand. Because, I used to spar with him all the time on Twitter. And after spending 2 solid days with him, I almost hate it for the public. I think some of the stuff that we talked about that wasn't recorded was actually really more interesting than the stuff we did record. And it was really done to stimulate him to go look at the biophysical level. I tried to explain to him in the podcast that most MDs, and I shouldn't say MDs either, I'd say MDs, PhDs, healthcare practitioners, no matter what degree they have, they operate at the classical level. The best fall into the second level, which is the thermodynamic level. That's where you're going to get high understanding of biochemistry. Only the truly elite get down to the quantum level. And what you need to understand, I explained it to him really simply. I said, every single boxcar that you have in biochemistry has an absorption and an emission spectrum. Your job, if you choose to accept it, as, say either a classic or a thermodynamic understanding practitioner, is to realize that there's a lesson for you to learn about the absorption and emission spectrum and how something really fits in. So let me give you an example of what we're talking about, because it's actually pretty operational. Because I was just talking to my nurse about this. We listened to a STEM talk it was just amazing to me how smart these guys are, and yet they made such huge mistakes. So I'll give you the example. David Sabatini, 28 years ago, went to Easter Island. Some Canadian guys gave him some fungus. That's where mTOR biology came from, okay? I'm not going to bore everybody with the whole story, but I'm just going to give you the TLDR so that you understand, because it highlights this question you're asking. The mTOR protein seems to be where the cell makes a decision between catabolism and anabolic state. No one has an earthly idea where it goes. For the last 28 years, people have written papers about mTOR. Now the latest rage into longevity, because that's where Rick's friend and Huberman's friend, just wrote a book that I rail against left and right, which is Peter Attia. He's got his own podcast called The Drive. Peter is the guy that's an expert that lives at the thermodynamic level. He's afraid to come to the physics level. In fact, Rick and Huberman both told me that he doesn't feel that he can have a discussion with me because he thinks that we're not talking. And I was like, look, the bottom line is, Huberman, you're sitting here with me trying to learn. I don't understand why he wouldn't do the same thing. But Attia holds Sabatini's work like godlike. meaning that he thinks that it's unbelievably important. He's built this practice in San Diego and New York around this. I mean, several patients that he's seen who didn't get the results they wanted have come to see me. So I kind of know what his practice is all about, what his beliefs are, and he's done enough work and podcast out there to get it. And Sabatini said something very, very interesting in the talk that was out there. And I knew this from the papers that I've, read on Sabatini's work, that we know a lot about mTOR, but you know what we don't know? We don't understand how glucose, oxygen, and phosphorus affect this pathway metabolically, but we know that it's rostral to the effect. So the thing I appreciate about Sabatini is that he'll actually say that in talks, he says it in presentations, and he says it in some of his papers. What I don't appreciate is that Peter Attia doesn't look at that paradox, because he's personal friends with Sabatini, and say, why is that? Okay? So I'll give you an example. I sat down here with Chantal and I said, I wonder when these guys are going to realize that mTOR has 380 nanometer light that determines whether you become anabolic or catabolic. All they have to do is look at the emission spectra of what's going on in mTOR. And I said, I wonder when they're going to realize that when oxygen tensions in a cell go up and down, that changes the VUV to IR light. That means you're changing the frequency of light in that pathway. I wonder when they realize that phosphorus actually makes up a wideband semiconductor. Like, for example, in the Huberman podcast, and we didn't get into the deep science. I'm giving you some of the ideas that were in my head that never came out. Phosphorus, everybody knows, is part of ATP, okay? ATP goes ATP, ADP, AMP, and adenosine. Adenosine gets you into sleep cycles. What people don't realize, what does ATP functionally do? It takes electrons out of proteins. What does that do? It changes the charge, okay? And when it changes the charge, that tells you that it's doing something to a semiconductive pathway by removing electrons. Well, what puts the electrons in? Well, that's where melanin comes in. Melanin is the condensed matter physics of POMC that charge separates water the best, makes more electrons than anything in human biology. So here's the other paradox. Sabatini says, we still don't know how glucose affects mTOR. Well, everybody should have woken up when Sabatini said this based on what I said to Huberman, because guess what? What makes glucose? How do mammals make glucose from light? Via ACTH, via cortisol. Cortisol is the level that Attia stays on, but he never gets to the level that I just brought you to. And you see, it's not very difficult to get to. Like, this leap isn't even a quantum leap for Attia, but yet he refuses to jump to that level, even though his friend understands that there is an issue with his own theory. Remember, this guy is nominated or on the short list for a Nobel Prize for this mTOR stuff. And you heard me wax poetic about all the people that I thought got Nobel Prizes that should have them rescinded. Getting the Nobel Prize is I don't think it's any trophy, to be quite honest with you. I feel the same way Feynman felt about it. He didn't even want to go pick his up in 1965. He had to be coaxed to do it. But the real issue, or what Sabatini's saying, I know there's more left to the story, and I don't know what it is, and I want to retire, but it seems like every time I hear a new piece of the story, I have to go back to the lab. Well, I'm hoping he hears your podcast and here's what I just said, because once you begin to realize, when you change the light frequencies within a tract in the body, okay, then you begin to understand why mTOR acts differently in muscles than it does in liver, why it acts differently in the gut, and why it acts differently in the kidney. All of a sudden, you sit back and go, this is beginning to make some more sense now. Now I can actually understand, functionally how this pathway works. And bringing this back full circle to what you asked me, this is really important for like the phaptic transmission, because what is melanin effectively doing? Not only creating the electrons in the system, but melanin absorbs all amounts of electromagnetic radiation, including ROS, RNS, and turns it in to metabolic energy that can be used for physiologic work. So it puts it into water. And what did we just say about Montagnier's study? That Montagnier's study, beyond a shadow of a doubt, shows that water has some amazing capabilities. And we know that every single wideband semiconductor inside of humans only operates when it's hydrated. This story that I just gave you literally in 5 minutes about Sabatini's work isn't that hard to get. And all you have to do is ask the question, why is it that we don't know after 25 years or 28 years of work since this paper got published, why we don't have any clue why oxygen, phosphorus, and glucose seem to really alter this pathways in a way we don't understand? Because we don't realize there's nonlinear optics going on inside the cell. What's going on with the biochemistry boxcars isn't really important. mTOR by itself isn't really important. All it is a major equalizer shift inside a cell that allows the cell to understand what's going on outside, what's in the environment in terms of nutrients. It nutrient senses, and then it senses via quorum sensing via light to the rest of the body. It talks to the leptin receptor in the brain to let them know what the energy balance is. Again, aren't we back to that leptin melanocortin pathway? Shocker. The pieces are all there, but I think the missing part for, Peter Attia's work, Huberman's work, Sabatini's work is what I just explained to Rick and Huberman. I think it's the biggest piece because it's the architecture of how we work. And until you understand that everything about biochemistry is at the biophysical level. In other words, I want to drag guys like Attia, because I think he's a good doctor. I want to drag him to this quantum level. Even though he's going to be kicking and screaming, it's the same thing that I get from several of my members and several of my ex-members and people who don't know my work. They're like, can you make this easier? Can you give me a Kruse for dummies? And I'm like, no, I can't, because that's not how nature operates, okay? Nature kills dummies. That's what extinction events are about. Anybody who can't adapt, they die, okay? Now, that's a hardcore way of putting it, but it's the truth. And when you're trying to uncover basic truth in science, when you're truly trying to change a paradigm, you have to punch people in the mouth to let them know that they're missing something really big. And when they understand what it is that they're missing, they fall back on their chair. Like when you teach them what I just said to you, everybody knows that mTOR is a big deal, but nobody knows why it's a big deal. And to me, the why is what they should spend most of their time doing, because it's clear in 28 years, they haven't found it in the biochemistry lab. Sorry for the rant, but I think it illustrates the point.
I think it's really important because a lot of people, even physicists, deny that biology can have a quantum effect because it's too wet. And I think fundamentally this idea of water and the semiconduction is vital for taking people to the next level, because biology...
I don't think you can be a physicist today, though, and have that position. The reason why? The 2007 papers on photosynthesis blow that out the water. The problem for physicists right now is now they know it happens in a warm, wet environment. And guess what? I would get on their case just the way I would get on Peter Attia's case. In other words, you have to do a better job. And to understand truly what biology is doing, I personally don't think is that hard to get based on what we know in physics. How does a warm, wet environment do it? Well, on the outside of the system that we have a vitamin D system that works with deuterium that's protecting the inside of the cells so that you can have magnetic moments that have nuclear spins of half. And it turns out electrons and protons have that. Deuterium has magnetic moment of +1. Well, light has an unlimited magnetic moment. I didn't even get into this with the guys in the Huberman podcast, but one of the things that we know about coherent light, that means laser light, is it appears to have an unlimited to infinity orbital angular momentum. What does that mean? That means that light can do things that we just can't fathom. And I explained to Huberman and Rick that the analogy that I used is we're all three of us would be sitting in a movie theater, and we'd see from the projector the light coming out. And we would look at that light and know the movie that's on the screen is inside that light. But when we look at that light or the projector, we have no earthly idea what reality is. But yet, when that light hits the screen, which is melanin, reality manifests. That is the idea that people have to get. So to give you the final thought here, Sarah, because you heard my analogies to Rick and Huberman about when the Human Genome Project came out, we found out we had the same number of genes as gorillas. That should have been a hard stop. Let me tell you what the hard stop should be for physicists. The hard stop should be the 2007 papers on photosynthesis. The other hard stop should be the Klitschko papers about magnetoreception in European robins. The other hard stop should be some of the stuff that Jim L. Khalili's already found out about proton tunneling in DNA. Okay? Like, it's futile to argue the point anymore. Now it's time to look into exactly what life is doing below the cell level. That's really the case. And to bring it back to the people who are probably at the reality level and the biochemical level, like the Peter Addies of the world, here's what I would like to say to them, because this is going to be a very big, encompassing statement. This is designed to punch your audience and the people that probably you talk to square in the mouth. Don't you find this paradox interesting? Here's another paradox I'm going to give you. That mTOR seems to work all the way up from worms, all the way up to mammals, but it stops at humans. Like, we have good data for mTOR that calorie restriction really works. But guess what? We have no good data that it works in humans. Ask yourself why that's the case, because last time I checked, Sarah, aren't humans mammals? What makes humans a little bit different? They've amplified two key semiconductors in their body plan, DHA and melanin. Hard stop. Why is it? Tell me why it is that calorie restriction data doesn't work in mammals. I'm going to tell you the answer is buried in that podcast that I did with Huberman and Rick. I've known that for 15 years. It's part of the reason when I was part of the paleo community, I went after Ron Rosedale, who's an ENT surgeon who is really big into calorie restrictions and limiting protein. The ideas around diet and how they affect this pathway make no earthly sense at all. In fact, all they're going to do is confuse the simple mind. And I consider most of the people with simple minds, the people at the reality level, the thermodynamic level, at the quantum level, where most of the people you probably interact with, which are physicists, they're going to understand, I think, what I just told you a little bit better, because melanin functionally is condensed matter physics. It's where AMO physics acts. It's the essence of what Schrodinger put in his book when he said, "What is life about?" The most stunning revelation that I think I gave to Huberman, I don't think it hit on him, was that melanin is now being looked at by the AI community as the most amazing semiconductor out there. It does more amazing things than even graphene does. And when you look at it, see what it's made of. It's a carbon-based semiconductor that's doped with certain atoms that are all wide band gap dopants. And it's hydrated. That's got to make you stop. And then when you realize that the light that's emitted from melanin is stronger than the light in the sun, that actually answers the question that Erwin Schrodinger brought up. He said, for some reason, life seems to skirt the second law of thermodynamics. And he coined the term in the book, negative entropy. What is negative? Negative entropy has been a bane of existence to scientists, both physics and biology. Why? Because it's so hard to wrap your head around what's really happening. And when you begin to understand that all life on this planet lived under a sun, and biology on this planet figured out how to make stronger light than the sun's there, all of a sudden you can see the mathematics change. That's how you create negative entropy. You create light stronger inside you that you can use physiologically. But it turns out the answer to your question, the one that I want you to go back to the scientists with, they need to understand that melanin in our skin with the visible spectrum of light is how you create the warm, wet environment to allow for quantum coherence to happen. That is the first step. So I give them that step to work on. Now it's time for you to get in the lab and start thinking about this a little bit differently, because what I'm fundamentally saying is that nature's been at this game for 4.7 billion years. She's way ahead of where we are in Taiwan semiconducting or in Silicon Valley. We're still at the silicon level where water destroys semiconduction. I would vehemently push against any physicist that told me that they don't accept that. I would actually go to this extraordinary step, what I'm about to say. That's a person I wouldn't listen to anything about, because their mind is closed. They're in their own silo and they don't get it. It's obvious that semiconduction is happening in us. It's obvious that quantum mechanics is happening below the cell level and giving us some of the very unique things that we see in biology. It's time to get our own frontal lobes out of our own way to see what's right in front of us.
Yeah, melanin is pretty amazing as well, because it absorbs absolutely everything too. And I think that alone fascinated me. It just absorbs every possible wavelength. Because then you've touched on another thing which people refuse to accept, which are non-native EMFs. And again, I just think, how can you not understand non-native EMFs and the effect they have on the body?
Well, this is another point of contention. Most people who follow my work know that I revere Doug Wallace because of the stuff that he's done around mitochondrial biology. But if you listen to his recent STEM talk that just came out, he says there's nothing published in the literature that links EMF to mitochondrial function. And hard stop. Remember, the silo that Doug Wallace is in is all about mitochondrial biology on the biochemistry side. He's the guy that's closest in biology to getting the answer. But when he says something like that, I guarantee at least my members will go, why does Jack revere this guy when he just said that? Because Doug doesn't know anything about what's in Andrew Marino's book. See, that's the domain of physics. And the crazy thing is, Doug's opinion, if you distill down his 45 years of work in biology, what is he basically saying? The anatomy in a tissue isn't important. It's the energy quotient that matters. That's a physics story. You would think the leap for him should be easier than it would be for Peter Addy and Sabatini to come to my level. But this was the thing that happened in the Huberman podcast that I realized, because Huberman's friends with all these people. He goes, Jack, these people are afraid to step out of their comfort zone. Therein lies the problem. Like, how are we going to get the real answers in nature unless we have scientists that are willing to go and step and put their toe in another place? I mean, you're in the UK. You got a guy just like that. Jim Al-Khalili is a nuclear physicist. He stepped out and looked, and he's interested in biology. People forget Feynman took 2 years off from physics to study biology. I mean, I respect people who do this. I have not seen that in biology. I haven't seen any biologist step out, interrupt their career, and start to study physics. I'm kind of actually hoping that Huberman does it, or he infects one of his medical students at Stanford or somebody in his lab to do just that. I mean, you got another guy. I just thought of a biologist who's doing it. It's actually John Joy McFadden, who works with Al-Khalili. He's a biologist that truly has stepped out and is now asking, the questions to me that are really important. And, even when you sit down with McFadden and Jim Al-Khalili, because I've heard them both talk, they don't understand my perspective either. Why? Because I'm way far down the rabbit hole than they are. They just need to come down the rabbit hole and see what I'm seeing. Because when you see it, it's really hard not to see it. Like, it's hard to remain ignorant of what's staring you right in front of the face.
But you're a bit like Gilbert Ling. You're so intelligent. It's really hard for you to If you had a projector, you could just beam into people's brains. It would be easier. But you're like the Gilbert Ling of light, that it's so beyond people at the moment. But then it's just about continuing to, as you say, punch them in the face with science until it goes in. Because that's what
Sarah,
the problem is.
I don't mean to interrupt you, but you just stimulated a couple of neurons in me about how you get physicists to really understand this, and it's tied to this Gilbert Ling story. How do I want to say this without coming off badly? Gilbert Ling was brilliant. His work ended up in an MRI machine. I said in several podcasts, not just the latest ones, but many of the ones I've done, tell me one machine that Peter Mitchell, his work on chemiosmosis, has created. So here's the thing for a physicist. Remember, most physicists have an engineering background. They understand that they're really reductionists that are trying to take the world apart to understand it. That's effectively what's going on at CERN. We're trying to take atoms apart at its smallest levels to understand the macro structure of the world. And that is an engineering idea. So physicists for me are like engineers. You've got to ask yourself as a physicist, how is it that Ling's ideas wound up in an MRI machine? And an MRI machine effectively studies things that physicists are really interested in, like how an RF pulse changes the precession of hydrogen protons, and we can generate different images on different relaxation. And then a guy like me uses them every day in my life when I'm in the clinic for patients. And it actually tells me about their redox potential. It tells me what's happening below the cell level. It tells me what's going on in the TCA cycle. Tells me if there's a deuterium shadow in a certain organ. To me, that is abject brilliance. So if you sat down with a physicist and they said, no, I don't believe that in a warm, wet environment, things are going on, bring a leaf to him and put an apple next to him. I said, explain this to me. Chlorophyll slows light down and you get this. That's E equals MC squared. Now reverse the process. Then you really want to screw them up? I'll almost hesitate to even talk about this. There's two major laws in physics. One of them I've done a pretty good job, I think, talking about. The other one I haven't done a great job, but I can tell you in my quantum engineering series of blogs, people are going to learn about it. The first one is mass equivalence, E equals MC squared. That was covered in the Vermont talks. It was covered in the EMF2 blog post. The other one that you need to know a little bit about is Noether's theorem. And see, physics has done a spectacular job with understanding Noether's theorem. Nothing, and I mean nothing, in biology considers Noether's theorem. And much of what POMC biology is about is actually about Noether's theorem. And you need to understand kind of what Noether's theorem is really about. So I'll give it to you as simple as I can, because I have never talked about this on a podcast. Her theory tells us this. And just so you know, Emily was a female at a time where it wasn't popular to be female in physics. She taught us with respect to energy and momentum that the universe, light energy, basically informs space and time how to curve. Let me say that again. With respect to energy and momentum, for light in all of the universe, not just in England or New Orleans or El Salvador, everywhere, informs space and time how to curve. So once you understand this, and it's not well understood in biology, what does this really mean? It means that the equation says, and this is Noether's theorem, the equation says that any symmetry, either local or global, implies there must be a conservation of some physical quality in reference to energy transformation to keep the system functioning. Why did I bring up mTOR and Sabatini and Attia? Mammals break time symmetry by conserving POMC biology. That is the reason why calorie restriction will not work in humans. Now, the reason Peter Attia and Sabatini are incapable of understanding what I just told you, because they refuse to come to that third level that I told you about. And I can tell you that when you don't understand how mass equivalence and Noether's theorem explain just about everything that has flummoxed me in biology, I can't stress it enough. And that's part of the reason why I've got to write about this stuff. And when people ask me why it's taken me so long to get to this story, Sarah, do you realize how hard it is to take the lay public from McDonald's to Noether's theorem or to mass equivalence? I mean, just think about how long it took me to go from the Vermont video in 2016 and 2017 to what I just said to you. Like, this podcast that you're doing with me is going to be someday just like those Vermont videos. Because this is not something that I talk about. This discussion we're having, these are the implications from the Reuben Huberman podcast that were in between the words. This is the stuff that you really want to know. Okay? Yeah, the other stuff people were happy with, but you'll see Jack is kind of bored by that stuff because that's been already in my head 20 years. I got a 20-year head start on everybody because I knew what rock to look under. Okay? Doesn't mean, Sarah, I'm smarter than anybody. I don't feel the way you do. I don't feel that I'm as smart as Gilbert Lane. You know what I am really good at? I'm a sleuth. I'm an innovator, and I'm the most curious person you're ever going to meet in your life. You give me an inch, and I will take a yard. I will not stop until I figure it out. That makes me a little bit more like an engineer, maybe a little bit more. Why later in my life I'm interested in physics more than I am interested in biology. To be truthful, biology bores me. I heard Peter Attia say multiple times, longevity is the hardest thing to figure out in humans. I think that is absolutely preposterous. I think it's blatantly obvious to figure out.
Oh, that's a really interesting one, because Stephanie Seneff's done a podcast with me and I asked her theory on aging and she said deuterium. Jerry Pollack said it's cosmic rays and positive ions. I think Aubrey de Grey is missing a lot. So I'm really excited for your view on the aging thing, because again, you've trashed not trashed, but you've proved to us about the calorie restriction. Then obviously the rapamycin is going to tie in with the mTOR. And this is exactly what I was getting to. There's going to be something to do with light. And then I was talking about T.S. Wiley in the beginning, because she was saying about people eating sugar out of season. We basically have 4 summers and that's aging us. But then I've never heard you sort of say it sort of completely unleashed what you think aging is, because I think there's way more than 7 pillars. And I think we've missed the point.
Yeah, well, I would tell you that the answer has been staring all of us in the face. This is where I give Doug Wallace this is the reason why I revere him. The wiring diagram in the inner mitochondrial membrane tells you the whole truth. And I did say this in the Huberman Rick podcast, but I think if you're not fast on sauce, you may have missed it. It goes back to Faraday's experiments in the 1850s. Basically, the FO head spins. You got electric current coming through. That induces electric and magnetic fields. So because the inner mitochondrial membrane is only 6 microns, that means the charge differential between them is 30 million volts. So realize that you have a lightning bolt present in every single crista of your mitochondrial membrane. So that tells you about power, okay? The other crazy thing about the electromagnetic force is that it gets stronger as scale shrinks. So, for example, the electromagnetic force in the sun is not as great as it is in your mitochondria. Let me say that again, because people will not believe what I just said. But it's absolutely the truth. As scale shrinks, the electromagnetic force, the force carrier of that force is the photon, becomes stronger. So when you think about what I've said about melanin, what I've said about wideband semiconduction, that we're able to make light stronger than the sun, and it's inside us. And I just told you about scale. You start going, wait a minute. Now I know where Jack's going with longevity. It turns out who's ever got the best mitochondrial redox wins the game of longevity. That's exactly what I've been saying for 20 years. But the problem is no one's really understood the wiring diagram of the inner mitochondrial membrane and leptin prescription. It's all codified there. So when you have the FO head, remember the FO head spins because of 4 red light frequencies. What happens on the inner mitochondrial membrane? You basically strip electrons out from food. So food is basically just electrons that are powered up by sun from photosynthesis. Okay? What's the key part to the calorie restriction in the mTOR story in mammals? In between cytochrome proteins, we have VDR receptors. That's the vitamin D receptor. So think about that when you're getting conversion of sunlight from your skin into your inner mitochondrial membrane, remember, that light cannot get from the surface to your mitochondrial membrane. But yet we have vitamin D receptors inside of us. This is Northern's theorem coming straight to your doorstep. Okay? And what happens is it interrupts oxidative phosphorylation. But why don't we die? Why does ATP still get made? Because red light stimulates the ATPase. So the combination of UV light, whether it's UVA, B, C, or VUV light, will stop electron chain transport. You will not need to eat. Why is that important? What's the other part of this, Sarah, that people have forgotten, that I've said ad nauseum? Cells put electronic energy at the electronic state, at the vibrational level. Why can we still make energy at night when we're sleeping and the sun's not out? Because it's stored in our bonds. How do you think melatonin releases its power at night? We all think it's a hormone of darkness. It's not. It's a hormone that's made during the day that's powered up. We harvest the light at night. And everything that's inside of us, all these chromophore proteins, what are they? They're there for a reason. Like one of the things that Huberman said that I really, really appreciated, because, the one thing that's always flummoxed me, he goes, why do we have so much melanops in our brain? We all know blue light doesn't get through our skull, except through our eyes, because it doesn't make any sense to me why it's there. After he heard the wideband semiconduction story, he was like, oh, now I get it. It's actually, we're using the light outside to create the light inside. I said, now you're beginning, and I didn't say this to him, now you're beginning to understand what Northern's theorem is all about, is that energy in the system is telling things in space and in time how to bend. It's actually how nonlinear optics really works. And all these chromophore proteins that we find, like the flavins, B12, vitamin A at 328 nanometer light, mTOR at 380. Like when you start looking at all these biochemicals that everybody knows and you start seeing absorption and emission spectra, and you understand what I just told you, you start to realize this is like a fireworks show at the 4th of July. And melanin is designed to absorb all that light and put any of the excess energy in water, which we use at night to store at the vibrational level. And remember, what makes the water in the cell? The mitochondria. What makes most of the melatonin in the body? The mitochondria. See, we're back to the story. Like where you can put me into the longevity story, it's all about mitochondrial redox. It has nothing to do with what Aubrey de Grey thinks. I think he's a smart guy, but he is totally co-opted by centralized science, especially the guys in AI and especially the guys in big pharma. I feel the same way about Peter Attia. Smart guy, but has not sunk to the level that we just went to. And they need to go there.
I want to thank my sponsor, Lightwater Scientific, who helped me deliver free valuable information to you and also allow me to have great guests on this channel. Lightwater Scientific produce the purest and most deuterium-depleted water in the world. Depleting or lowering your deuterium has numerous health benefits, from better metabolic health, more energy, greater resilience, less brain fog, increased physical performance, enhanced healing, and healthier mitochondria. Deuterium is an isotope of hydrogen, also known as heavy water, because it's bigger and heavier than regular hydrogen. Even though deuterium makes up only 0.02% of hydrogen, it's found everywhere. Deuterium is a burden to your body because it interferes with the intricate chemical reactions that occur by slowing them down. Deuterium is kryptonite to your mitochondria, and we need healthy mitochondria to produce energy. There's over 60 years of scientific research on the negative effects of too much deuterium on health, and also the positive benefits of lowering deuterium in the body. Light water, deuterium-depleted water, is 100% safe and non-toxic. In fact, it's the closest in structure to the metabolic water that your mitochondria produce. Light water, deuterium-depleted water, comes in 5 or 10 parts per million glass or plastic bottles. So level up your health by leveling down your deuterium today. The purchase link is in the show notes, and use code Dr. Sarah for a discount off your order. That's really interesting. So I was just reading up about magneticos, and again, anything that can raise the membrane potential or the charge at the membrane is going to have massive effects. Because again, I was going to ask you what you thought about magnetism and anti-aging, because obviously Dr. Dean's passed away, and I'd love to carry on his research actually, because there's so many things he didn't do that I'd love to do. And just your thoughts on.
I think magnetism has two main effects. There's an exogenous and an endogenous effect. If you were to ask me, I think they both have to be operational at the same time. Not to go too down far the rabbit hole. Do I think the unipolar system that he built helps the external issue with electromagnetic pollution? Yes, but that's not the big part of the story. The big part of the story, if you're following along at home, when you take E equals MC squared and put it next to Noether's theorem, I begin then to open physicist eyes, because do I believe the biggest mistake in physics was when Oliver Heaviside shortened Maxwell's equations from 20 to 4, and we lost the ability to realize that there's a potential for a magnetic monopole. Do I believe magnetic monopoles that really influenced Paul Dirac, who was a physicist in the early 20th century, who was very popular in England before quantum mechanics was laid out? Remember, from this work, from going back, Dirac went back and looked at the original equations of Maxwell before Heaviside made it. He dumbed it down. Like, people always ask me, why won't I dumb down my information? I'm actually telling you, Sarah, here's the real reason why. When I saw a physicist dumb down from 20 to 4 equations to explain electromagnetism, we lost the ability to understand that a magnetic monopole is actually possible by the mathematics of James Maxwell Clerk. Okay? And because we don't see monopoles in nature, this has, how shall I say, been the comfort to physics and to biology. Therefore, we don't have to worry about them if we don't see them. But what I think they don't realize is that magnetic monopoles are an emergent property of matter. And that happens endogenously via nonlinear optics. Okay? And that ultimately is one of the key power sources. It's not just light and ATP. There's multiple sources of power that are available to cells that we don't know. Like, the amount of energy that I'm trying to tell you that we store at the electronic and vibrational levels will absolutely stun physicists, when we find this out. I think that we have more power in us as alive sentient beings than people could ever harness. Somebody asked me at a dinner party once that I think we had over 1 trillion millivolts in us. I said, how many trillions? We may be in the quadrillions. We may even be bigger than that. And the reason I say that is because when you understand the human brain as I do, it's the first true quantum computer. I shouldn't say true. It's just the best iteration. The first one was probably the cephalopod brain that innovated right at the Cambrian explosion. But we're the latest version of it. And we have the most updated one. To run quantum computing, to work on electrons, protons, and photons, you have to have tremendous energy and power. So it becomes incumbent upon the physicist and the biologist to explain where that energy and power come from. What led me down this path was Noether's theorem and also E equals MC squared. I realized when I saw the nuclear bomb explosion how much energy could be unleashed between two elements in atoms. And that's when you think about the things that I'm talking about with wide bandgap semiconduction. It's not hard to imagine that you can pull this type of energy out of magnesium, calcium, sodium, phosphorus, nitrogen. And when you look at chlorophyll and see it in a nitride cage, with 12 electrons, and look what it does. It creates all the food on the planet and all these beautiful trees that are, around me. And then you think hemoglobin has been the wideband semiconductor that basically innovated most complex life. It actually worked hand in hand with mitochondria to actually get to this melanin story. Don't think that melanin is a late biologic creation. I told Huberman this, and he didn't know it, that cephalopods used ink that's made out of 70% melanin to get away, or when they got bit. I said, we now put that melanin in our own white blood cells so that when we get injured, that's what determines how we heal. That story now is linked to autophagy, apoptosis. It's linked to mTOR. Remember we talked about catabolism and anabolism. How do you turn off? Let's just go for the whole shit and caboodle here. How do you turn off inflammation? You hear all these bro science guys in nutrition talk about omega-6 pathways going down to arachidonic acid, and you see my profession right now says, let me give you Advil, let me give you non-steroidal anti-inflammatories. But 20 years ago, people remember the Vioxx story of Bextra. We caused people to have heart attacks. Think about that for a minute. Ask yourself a question. Why'd that happen? Because there are mitochondrial toxins. Turns out if you're going to use a non-steroidal anti-inflammatory, you probably should use aspirin and not non-steroidals. You know why? It goes back to this story about fats. You know why? The guy that taught me, that helped me on my journey as a neurosurgeon, is Nicholas Bazan. I taught all of my members about the short and long loop of Bazan in the eye. But his greatest discovery that he should get a Nobel Prize for, but likely won't, was that omega-3 catabolism breaks down into resolvins, protectins, and merisins. You know what they really do, Sarah? That's what turns on to eliminate inflammation and to start catabolism and wound healing. And you need massive DC electric current for that to occur. That's also why I told you about the 380 nanometer light tied to the mTOR pathway. You need UVA light in order to make the decision. So you know what that means? From 380 down, you're able to rebuild tissues. From 380 up, you're not. That is the story that's being built. So it turns out in mammals, in us, the two most important wideband semiconductors are DHA and melanin. That story, if you go back and look at every blog I've ever written, anything I've ever said on a podcast, it always goes back to that. But you know what nobody really knew? That E equals MC squared and Noether's theorem held the real key. It's the physics of those two chemicals. That's the key. And what makes me really happy now is one of your countrymates who I really respect, Sir Michael Crawford. Mm-hmm. He wrote a beautiful paper in 1999 about DHA to him appears to be some type of quantum chemical. He was absolutely stunningly correct. He's never been given the credit that he should have given. He's at the end of his life now. I think that discovery someday will turn out to be as big as Newton's discoveries. Okay? But you need to understand, Bazan made good work of Crawford's idea. He basically told us that we now know how to turn on the POMC of neutrophils and white blood cells to go from inflammation to tissue rebuilding, to regeneration. That's the work of Becker. That's the stuff that you heard in Ruben's podcast. What am I doing for you right now? I'm filling in a lot of spaces between the story, aren't I? There's a lot more to this. When people see me on Twitter and I said, look, you think this is interesting? I'm just warming up. I got a lot more to go. I'm not even close. There's a lot more science to teach people. For those people who are interested, they'll stay and they'll pay attention. For those who want to dumb down, go listen to Peter Attia's podcast. I'm not interested. I'm not interested in mammals that are not interested in the story of us. I'm interested in that story.
Yeah, what you've said has sort of stimulated lots of things in my mind. The first
Good.
one, just to go back to the massive amount of millivolts that's held in a person. Do you believe in spontaneous human combustion? I know I'm bringing quite a lot of woo in, but then I love...
No, I don't.
Because I was just, when you said that, I thought, I wonder if, I know there was a big craze on it a long time ago and nobody proved it either way. And when you said how much charge a human holds, my little brain thought, I wonder, I like dispelling myths and stuff.
I will tell you this. Maybe let me give you a spin on this. Maybe you'll like this better. I think that I just caused a spontaneous human combustion in your brain by telling you what I just told you.
Yeah.
Do I think that a thought is an endocrine secretion that is mitigated by VUV-IR light? Even though we're doing this over a Zoom call on the internet, do I believe that I am capable of putting something through the melanin in your ears, the melanin in your nose, the melanin in your touch, the melanin in your eye, so that it tickles your orbital frontal gyri and the melanin sheets in your head to say, what he just said, I have a lot more questions. Because guess what, Sarah? That's how good science is done. In other words, you don't seek the answers. The answers you get lead you down to deeper rabbit holes. And you start going, So I think the more interesting thing is that you can sit across from me. We can have this discussion. And I guess I'm going to change my answer. There is spontaneous human combustion in ideas, in our imagination, in the way we think about things. Why? Because what makes humans so amazing is that they can see the world. Like I'm looking right now at my world and seeing two birds feeding on my feeder and seeing my dog right in front of me and seeing my nurse sitting over there listening to what's going on. But at the same time, in my imagination, I can imagine what the world should be that's not present today. I can take myself to a completely different place in the world inside my mind. I can imagine a different spot. I can imagine what the day is like today in the UK. I can imagine what the day is like today in El Salvador. I can imagine what Peter Attia or David Sabatini are going to think about listening to this podcast. I would imagine some of the physicists that you'll show this to. Some of them will say, this guy is an absolute quack. Or they're going to say, this guy is probably one of the most interesting guys I've ever heard talk, because you know what? I've never thought about science from this facet. And guess what? That's what we're talking about. Science is a big diamond, and we all come at it from the facets that we're more facile with. And what am I trying to say, Sarah? Start getting familiar with the facets that you're not familiar with, because guess what? Ultimately, they're going to lead you to spontaneous human combustion in your mind.
That's also reminded me of Rupert Sheldrake and consciousness not being in our actual heads and us being able to project thoughts through time and space. And I know you had a
Stop for a minute. What did you just say? What did you just say? I'm stopping you again. You just basically said Northern's theorem.
Yeah.
You see that? You understand Northern's theorem through Sheldrake's work in his eyes.
Yeah.
See, I want to erase Sheldrake too. I want to go straight back to Emily Northern, because she's right. And what you just said, Sheldrake is also right. But the thing is, to not be ostracized in science, you have to show people why they're right.
Yeah.
And in this podcast, I just told you, you need to understand Northern's theorem in biology really, really well, because then all of a sudden, certain questions you ask, they're not so counterintuitive. Actually, they're quite logical. I like that. 2 ohms in a podcast, that I can tell you, that's usually when I know it's going to be a good podcast.
Yeah, because the thing is, like, I really respect Rupert Sheldrake, and because you've mentioned E equals MC squared so many times, and he unearthed the fact that C is actually a variable, not a constant, and then they fixed the constant of C. I always think that whenever somebody says E equals MC squared, and what's the significance, and does it even matter, or whether Sheldrake
think about what I said to you.
Yeah,
that UV light, we're creating light in us, and not only that, didn't I just say to you that the stuff that Sabatini and Addy don't get, that phosphorus, oxygen, and glucose change C squared. It's not constant. You're absolutely right.
Yeah.
He's right. That is going on in us every time Wim Hof takes his breath, or you take your breath, or you're in a tub in Finland, and I'm in a cenote in Mexico. We are altering frequencies of light in us. That has immediate consequences to equals MC squared. It has immediate consequences to how light will bend space and time inside of us. See, it's not that hard to get. No. You don't really need to know a tremendous amount. You just have to sit back in your chair and go, man, I've been coming at this the really wrong way. And when you realize that at the seat of all of this is how we absorb light and how we create electrons. Because guess what? That's the game of life. All you need to do to understand life is understand that we have to collect electrons. So when you ask me about consciousness, I'm going to tell you, complex life, meaning humans, are more conscious than other mammals because we collect more electrons. Doesn't mean that the whale's not conscious. Doesn't mean that the dolphin's not. Doesn't mean that the little furry creature at the KT event wasn't conscious. It's just like Einstein said, everything in the world is relative. Not only time, but so is consciousness. And I actually said this in the Rubin podcast. I don't know if you heard it, but I said I can alter your consciousness very easily in my operating room with the general anesthetic. I can actually bring you certain levels. If I just hit you with midazolam, and don't give you any general anesthetic, you're just going to be goofy. You're going to start telling me stuff, about your husband that you probably don't want me to know. I can give you another drug to get a different reaction out of you. But ultimately, when I give you the general anesthetic, the inhalational, you're out. I take your DC electric current away in your brain. So when I see that every single day in surgery, realize that I view consciousness way different than probably most physicists and probably most biochemists. I realize that it also is a function of redox potential. And when you understand that, basically what I'm saying is those trillions or quadrillions of electric power we have in us, anesthetics interrupt that power. That's what takes our consciousness away and turns us back into the original 2 domains of life, archaea and bacteria. And ultimately, what is a mitochondria, Sarah? Bacteria. It's the combination of both of those things, isn't it? Makes total sense, doesn't it? In other words, isn't that Mandelbrot's fractal geometry right in your doorstep? That you can take a human being who's a eukaryote and turn him into a prokaryote or archaea by putting him to sleep. Weird way of looking at it, isn't it?
But that's the fact that we're full of bacteria is really important because their DNA mutates so quickly, whereas human DNA is really slow. So that's kind of triggered another thought in my head about,
think about what you just said.
What am I? I don't, what are we?
You're an alien. That's what you are.
Yeah.
And, people don't look at it like that. But, you said something that's more fundamentally profound that Wallace has said. The amount of, when you understand and remember that mitochondria are fundamentally bacterial origin, remember, those 37 genes, 13 of which make energy, they're far more likely to mutate. That's the reason why energy and heteroplasmy link. That's the story of longevity. That's where I cut right across Aubrey de Grey, Peter Adia, any of the other people out there. They're not making these basic connections.
What about David Sinclair? Because we haven't mentioned him and his aging theory of the epigenome and the ornaments on it and stuff. But
I don't look. I have to give this caveat. David Sinclair's best work he's ever done is the 2013 paper that he links pseudohypoxia to aging. Everything else David Sinclair has done in science, to me, is absolute robbery. And I mean that in a literal and figurative sense. Remember, he sold the story of resveratrol to GlaxoSmithKline, UK company, made $400 million and basically lied through his teeth. Now, I can tell you, I talked on the Rubin podcast about that. That didn't make it. They cut that out. Why? Because they're friends with the guy. Okay? But I'm telling you, I don't respect anything else he's done because every bit of his science is done to harvest and make money from Big Pharma and from people. And I think the public has a duty to know that.
And also, none of it's on humans anyway, because all the sirtuin studies are all mice, and mice are nocturnal as well. That's the other thing that really annoys me.
But just think about what we talked about earlier in the podcast.
Yeah.
Not only are they nocturnal and they have different retinas, but remember what I said about mTOR. mTOR, it works between yeast and primates. Where does it stop? It stops at gorillas. Okay? Doesn't mean anything you find in those lower mammals is the same. Now I want you to think about the magnitude of the implications I said in the podcast. Did you hear me use the word incalculable? Mm-hmm. That how many mistakes we're making. If what I just said to you is true, you realize that everything in the nutrition literature should be thrown in the garbage because it's all done on mammals that are not like us. Think about it. Not only are they studied in a blue lit lab with electromagnetic radiation around them, but they don't have the epigenetic toolbox we have. So if you really want to know what I think about David Sinclair, I kind of just told you. I think he's a clown. If you want to know the truth, I wouldn't listen to anything he has to say. Why? For me, he has no face validity, and I think he's unethical. How's that for not parsing words?
The thing is, the way of eating he suggests really harms women, and it'll give them osteoporosis. And the thing is, I agree. I think it's just what I do is I just get upset at people being deluded, and this is why I get really cross about micro content and not letting people just say what they want, because the public gets deluded, and very good communicators who are unethical cream, the public's money, and it hurts them. And, there are certain supplements that, I've used to love them, and I'm the same, I just go through phases, and, I have a few things left that I like deuterium depleted water. And I suppose bioidentical hormones, like the sex ones, are the few things I think people might need when they're older. But then I just start to see through, and I feel bad for suggesting it to people. That's why, the nonsense needs to stop. But,
I can't say that I disagree with that. I would tell you, I think I said in the Rubin podcast that the only two supplements I can get behind are sunlight and deuterium depleted water. Why? Because both of them are natural. Mitochondria makes it, and the sun is the power source, as Rick likes to call it in his book, the source that controls the whole show inside of ourselves.
Yeah, it is. But also I think it's, creatine, I suppose, is all right as well. And then I know that you are in two camps now about methylene blue, that it's got uses, but again, that's going to explode out into the population, and people don't understand how methylene blue works.
The problem is that the whole point of bringing that up on the podcast, just so you're clear, Rick reached out for my help when he went through his issue, and I told him something that was pretty novel, and I explained to him that this would be I guess an auxiliary anesthesiologist in the room with him that would protect his brain and his melanin sheets and his cochlea when he was on pump, when all his blood was in a machine. The crazy thing is he ran it past the Stanford heart surgeon, but also Peter Adia, and they both told him it was crazy. And the crazy thing about the whole story was Rick didn't tell anybody, but after surgery, he continued to use it. And he continued to see benefit. And of course, I'm not going to tell anybody's dirty laundry, as a doctor. But when Rick agreed to talk about that on the podcast, that actually, believe it or not, was the main reason I agreed to flew to California. Because I said in 2015, I would never be back in California in my life.
Yeah, the thing is, I think that's really important. That's triggered another thing, because I'm just reading your latest blog, and when it says that autism rates are highest in the whole world in California, yet you'd think it's the most educated, the most healthy, and the most wealthy. Well,
the reason why it's like that, and this is what people don't understand, if you understand the thesis that I laid out in that podcast, basically that the retinal hypothalamic tract is the gun that shoots at melanin targets deep in the brain. I made the comment that anything with the name thalamus in it is a target of the retinal hypothalamic tract. Well, the distal end, in neurosurgery, we call things caudal and rostral. Rostral being the head, caudal being the tail. The tail end of the retinal hypothalamic tract is the human thalamus. What does the human thalamus do? That's where all five senses congregate. They're all there. That's the defect that's in autism. What happens in the thalamus in the embryo? The thalamus undergoes what we call neurulation. Neurulation creates the hemispheres above. Mm-hmm. So when you understand autism functionally, it's a defect in POMC biology that eliminates melanin somewhere in that tract so that neurulation is defective. This is the reason why the kids have a huge problem with sensation, being touched, sounds, bright lights, anything like that, because every single sense, most people, I'm surprised, don't know this. You don't have a sense in your body that doesn't use melanin. Like when I told people in the blogs, in the quantum engineering theory, that you have to use light to hear, people couldn't believe it until I showed them a picture of the cochlea and then showed them papers that said I was right. Same thing true with smell. That's why Turin's more right than the guys that Huberman loves that got the Nobel Prize for the lock and key mechanism for smell. Same thing is true with Pacinian corpuscles and touch. Same thing is true with any sense. Melanin is the key semiconductor for sensation. So when you understand that autism is a sensory deprivation, or how shall I say, almost a synkinesia or an akinesia of sensory abilities, most people never take the next step where they go back and say, well, neurulation only occurs from the thalamus. So that's the reason why the defects are present between different parts of their hemisphere. That's the reason why there's a spectrum, because wherever the melanin defect is where the kid's going to be autistic the most. And the other part of the story that I haven't gotten into, or I didn't get into with Urin, but I did get into with an MD from Australia. His name's Max Gilhane.
Oh, yes, yeah.
I did a podcast with him that hasn't been released yet. It's the second part of the water story.
Oh, it has been released. I watched it. I've started watching it. It was out a week ago.
No, there's another one.
Oh, is there part 3?
Yeah, there's a part 3 that hasn't been released, but in that one, I explained to Max that most people don't realize why this story of autism is really important for people to understand, because there's another physics part, and this will probably be something that will tickle you because it brings you back to the magnetic part of the story. The human thalamus is where the alpha wave in the EEG comes from, okay? That wave is 7.83 hertz. That mimics the heartbeat of the Earth. So via molecular resonance, the heartbeat of the Earth that's created from the cathode ray of the sun hitting the anode with the magnetosphere around it, remember that sun keeps magma flowing in the planet. That creates, Faraday's idea of a magnetic field. The magnetic field, that's how it's informing your brain how things work through this thalamic relay. So the caudal end of this retinal hypothalamic tract, this story, the answers and parts are all there. This is the reason why, defective sleep always comes. If you're on the rostral end, it comes with alterations in vitamin A. The distal end, it comes with problems related to the alpha wave. And what sits in the middle of that pathway, I actually told you that in this podcast already. ATP, ADP, AMP to adenosine. Adenosine is the middle part.
Yeah.
What stimulates adenosine? Red light. All red light, bright, huge, intense red light stimulates adenosine. And the reason why, if there's any doctors that listen to this, they'll be stunned at this. On our crash cards for ATLS and ACLS, I'm talking about physicians, when somebody gets SVT, which is supraventricular tachycardia, that's a bad rhythm from an alien DC electric current in your heart, guess what the drug is you give? Adenosine. That tells the clinician immediately they have a problem with either vitamin A in the brain or they have a problem with the Schumann resonance in the thalamus. But none of them realize that.
Wow.
Exactly. It's kind of cool stuff.
Oh, it's amazing. Because on the subject of this and magnets, what's the real cause of bipolar disorder? Because sometimes the name of the disease is in the name. And again, what schizophrenia is slightly different, but I don't buy the current idea about bipolar just being a
I did say
metabolic.
this. I did say this in the Uber podcast, but I listened back to it and I realized I wasn't clear.
No, it's not, because I was really
Maybe,
interested in bipolar disorder.
maybe I can give it to you like this. I want
Hmm.
you to think about all human mental illness as a bowling alley. The two gutters on either side. One is depression. That's the low dopamine state.
Hmm.
And schizophrenia is the other gutter. That's the high dopamine state that's released chaotically. Bipolar disorder is in the middle, but closer to schizophrenia. And the reason for that is defects in the retinal hypothalamic tract that go to the habenular nucleus that then get relayed from the hypothalamus and the thalamus into the orbital frontal gyri to affect the reward tracts. That's actively what happens. The single big effect is that tract is out of whack with the oscillations of the same tract that goes from the RPGs into the suprachiasmatic nucleus. So to get bipolar disorder, you have to have the hard tract that I just gave you, plus you have to have the circadian mechanism completely broken. And what people don't realize that the initial part from the retina into the hypothalamus is actually the same tract. Remember that the retinal hypothalamic tract synapses in the SCN and the habenular nucleus. They're both the same. So it means the gunshot is the same. But to get different diseases, what happens if one tract is out and the other one's not? Okay. Or what happens if they're both out? That explains the difference. Okay. And with schizophrenia, it's the third tract. It's all those tracts that go from the thalamus that radiate up into the frontal lobes. They all have to be damaged. So what you're basically seeing, I use the analogy in the podcast that it's almost like a train station. Which part of the train station is damaged on the line? You know that a line like in the underground in the UK has 20, 30 stations. Well, what I'm saying to you is every mental disorder is damage to a different station along the tract from the eye or the skin all the way through. Like I haven't talked about the skin too much because understanding from the eye is easier. But believe it or not, do I think there is an issue between the eye and the skin? When you give it a mismatch, like by wearing clothes, you're much more likely to actually have a mental illness. And if you really read my last blog, what did I say creativity was a function of? It's a regressive evolution. I believe that we became more creative just by wearing clothes. And everybody looks at creativity as a positive thing like Rick does. I don't. I think it's actually shows us the de-evolution between Neanderthals to us. Because Neanderthals had 125 grams more tissue in their head. We have less. And what happened with Neanderthals? When they left the East African Rift, they went to your latitude. What did they do? They started wearing skins. What's the first time we ever saw human creativity ever? Cave paintings. When Neanderthals and humans both lived on the planet. That's where artwork came from. It came from a lower dopamine state from our original state. So if you understand what I just said, are there levels north or rostral of human evolution? The answer is yes. I believe since Neanderthals, I believe since last 25,000 years, humans have been de-evolving. And we have changed our frontal lobe's abilities. Most of the thing that you find interesting in the Louvre, in science, and in art, there's a reason, Sarah, they call them the Dark Ages. Remember, you're a UK girl, so you can go tomorrow into the museums, and I hope you do this. And when you go, I want you to do it with this eye. Look on the wall about how artists painted with light in 1200s versus how they painted with it all the way up to Monet. And you'll notice something startling. And you'll also notice and have a new appreciation for Michelangelo and Da Vinci's work. They were known as the artists that painted with light. Who was the first guy that innovated light? Rembrandt. You're going to start to see this story of that dopamine state. And then you're going to go back and look at those slides that I take from Alexander Wunsch and keep telling people, look at the top. Tyrosine, phenylalanine, T3, L-dopa, melanin, dopamine, and noradrenaline. And what you're going to begin to realize from Noether's theorem, not only does that pathway work left to right, it works right to left. And right now, you're a modern mammal who your entire human existence, the entire history of humanity, has been lived when we're going the wrong way. How do you like that?
I was just about to say before you said it, do you think we're devolving? And you just kind of read my mind and answered it. So we think we're evolving and getting cleverer with all this AI, but we're actually getting weaker. And I have wondered this. That's why I opened this up with something like temporal lobe epilepsy that is quite wacky and could be superpowers. But then it's all these things that are actually us being more creative is actually us getting stupider in another way. So that's kind of really...
I wouldn't say stupid. I would just say it's a different, you know how like science, the idea if you're not a Copenhagen person, you're more, say, a many worlds person.
Yeah.
This is just, I look at evolutionary shoots as a many worlds problem, that we just went down a different path because the energy in the system changed. Remember what I said to you about Noether's theorem?
Yeah.
That space and time curve, it tells it how to curve. Basically what I'm telling you is every single trajectory, like all the trajectories that hominids took and whales took, you should not think of them as good as bad. I want you to think about them as information or energy and how information and energy changes. This gets back to Sheldrake, saying that C2 is not the constant. Light changes, and as light changes, it sculpts life. Now we're back to Roland Van Wyck's ideas. You see, when you're this facile with the science, you begin to see everybody's got a little piece of this. I'm the guy that tries to make sure that everybody sees the whole part of the elephant. I just don't want you to touch the trunk, the leg, the tail, or the eye and say, oh, this is what life is. I kind of feel that some of the guys that we mentioned in this podcast, they've touched the elephant like Aubrey de Grey and said, oh, well, it's all about this. Or David Sabatini, well, I've touched mTOR, it's got to be about this. And Peter Addy is a disciple, like Huxley was a disciple of Darwin and said, this is the way it is. Mm-hmm. Uncle Jack doesn't play ball like that.
Okay, another one into this then, back to Sheldrake and bringing Carl Jung into it and the collective unconscious. So if I think we're getting a bit stupider but more creative, do you think that the collective unconscious, if it exists, and Rupert Sheldrake has got lots of evidence about morphic fields and information traveling through the ether, is that compensating for us wearing clothes and becoming, maybe not stupider, but what do you think about that?
I think we become something different. And could we become something better? The answer is yes. If you really want to know where I think this ends, you basically just stepped into the world of SETI. This is what NASA does. Like I said this to Yerberman on the podcast. I said, I believe that we could go to a planet someday with our technology, stare life on another planet straight in the face and not even realize it's alive. That's exactly what I'm saying to you. Mm-hmm. That I think when you take what you think is interesting. And this is the funny thing, I almost want to tell you this, but I don't want to because it's another rabbit hole you're probably not going to like.
Oh, no, I love rabbit holes. I've been down that many.
He's a countryman of yours, so you should really know about this.
Yeah.
But instead of being fascinated by Sheldrake, because I find him not very interesting.
Oh no, I've moved on. I like him. There's lots of people I like, but I get an idea, then I have to explore it from all other angles.
I want you to go to Turing. I want you to go back and read Turing's paper.
Oh.
In 1951 about morphogenesis.
Right.
Go back and read that paper and tell me that guy wasn't fucking brilliant. What your government did to him was absolutely a catastrophe. But I think he was one of the greatest minds of the 20th century that clearly was muted way before. And I personally believe that a lot of the things that resonate with Sheldrake actually come from that 1951 paper. And the reason I think I'm not really excited about Sheldrake is because I know where the idea came from. It's Turing's ideas on morphogenesis. Like he explained the reason why orcas have the colors they are, why cows have the colors on them. I know now why, the frontal lobe and the temporal lobe look the way it does because of what Turing, put down. And when you understand what Turing's really done, he set the stage for modern computing. And then who gave it life was, Claude Shannon from Bell Labs. Those two guys together, putting them together, gave us the thing that's killing us, gave us our asteroid. But do I feel bad about Turing or Claude Shannon? No, I feel bad that the people that took the torch after they died have not realized once that we need to look into how we're using light to communicate. Because remember, when quantum mechanics was innovated from Tesla to Niels Bohr, no one ever thought, and because remember, biochemistry wasn't even out then. No one ever thought that light could control the biochemicals in us. We still don't realize that today, Sarah. And that's the real problem that I'm trying to solve. I want people to understand that these scientists came up with great ideas, but the problem is when you have a great idea and don't understand that you're causing harm, effectively you're operating in the Dunning-Kruger effect. And that's kind of where we are right now, where what we don't know turns out to be the biggest things that are harming us. It doesn't mean that I don't have a reverence for Turing. It doesn't even mean that I don't have a reverence for Sheldrake. It means that I think you need to go back and really look about what they said so that you understand morphogenesis. There's another facet of that diamond that can actually help you sit down with physicists that fundamentally do not believe that order comes from chaos. Like, I would really hope if you have the opportunity to take this podcast and show it to a guy like Jim L. Clearly. One of the things that I really respect about him, I make most of my farm members sit down with me and watch a video that he did in the BBC. I think it was in 2011, 2012. It's probably the best thing he's ever done. It's a BBC video that says Order and Chaos. And he explains, many different things that are bizarre in physics that have stunned people. Like, for example, the Belousov reaction, where you can actually take glucose and certain chemical and it can turn the color from yellow to white back and forth with no energy put back into the system. Yeah, I'm glad that you just did that, because guess what? It almost suspends your disbelief. But what's happening at the quantum level, whose paper, the most cited paper in science, you know what it is? Brownian motion by Einstein. One of the 4 papers from his miracle year. It actually happens because of proton tunneling in there. That's why Khalili's so interested in it. But the point that I'm trying to make to you is the foundations of quantum biology are how, this is the real question that physicists and biologists need to have coffee over, or wine over, or brandy, whatever your choice is. Let's explain how order comes from chaos. Because all the laws of Boltzmann, Clerk Maxwell, everything are focused in and around those laws. And then when you get into the guys that came after them, the real deep thinkers like Ilya Prigogine and Arrhenius, who came up with the 4th law, and the laws of thermodynamics that really control quantum electrodynamics and dissipative structures, that's fundamentally what we are. Like, I just spanned huge levels in physics. And the thing is, physicists know that these things are there, but I don't think we're examining them the way we need to examine it. And Order from Chaos, when he put that video out for the BBC, it was spectacular. Anybody who's a mitochondrial needs to watch that video. And I promise you, when you watch that hour video, you will fall back in your chair and go, now I know why Jack says he's just warming up. There is so much to know. I mean, if someone was to ask me what my biggest regret in life is that I can't live to be 200 or 300 years old to keep unfolding this onion back. Because this is the most fascinating thing I've ever seen in my life. To understand life and nature at a fundamental level has been the one thing that has tickled my curiosity from the time I was a little boy. And I still don't stop being tickled by it. Every time when I talk about it, just like I'm talking about it now. That's what I'm passionate about. And the thing is, it stuns me when other biologists and other physicists aren't stunned by some of these paradoxes, that we talked about today. And they're not stunned to really want to study them or look at them or understand why Turing and Shannon and Sheldrake and Jim L. Khalili and Richard Feynman and Erwin Schrödinger and Ilya Pirogine and all the scientists that we mentioned in this podcast, they're all connected by a fractal nature. That fractal nature we now know is tied to Mandelbrot's geometry. It's beautiful. And, in El Khalili's his video, if memory serves me, because I haven't seen it in a long time, I may watch it tonight. He actually puts a gorgeous picture up of one of Mandelbrot's fractal pictures and says some of the most provocative stuff when it's up there. And I just watch things like that and I go, why do people want to talk about is meat good or bad for them? Why do people want to talk about carbohydrates when you have something that is this amazing? This is something to be discovered. Eating a hamburger, who cares? Who really cares?
One of the things that really fascinated me about biology is, have you heard of a bacteria called Deinococcus radiodurans that lives in nuclear reactors, and it can get its DNA and chromosomes blown up and then it rebuilds them perfectly? So that's the kind of thing, like, okay, how does it do that? But knowing what I know now about light inside the body, I'm kind of thinking, hang on, I think I can work this out. When I was doing my PhD, it fascinated me, all these different bacteria doing crazy things, like bacteria eating mercury and oil slicks and bacteria eating explosives and stuff like that. And it's like you say, I'm much more interested in things like that than whether I should eat cheese or an egg or whatever. So yeah.
Yeah, I mean, people have to remember that the first domains of life, archaea and bacteria, were on this planet when oxygen wasn't around. So they had to have another terminal electron acceptor. All those things that you just mentioned were the original terminal electron acceptors.
Yeah.
And, that's like version 1.0 of life. Now we are in version, 1,150,000. And why people aren't interested in what happened in the past to explain the future, like the things that you asked me about, the trajectories that I can see, I don't really look at evolution as a good or bad process. Like when I make the comment about a cognitive de-evolution, Sarah, I want to be clear about this. As a brain surgeon, I don't necessarily think that's a bad thing. And hopefully I made that point to you when I tried to get you to think about cave paintings and Michelangelo. Without us wearing clothes, like what's the collateral damage? We don't get Michelangelo's David. We don't get the Sistine Chapel. We don't get, whether you like it or not, Rothko, or we don't get, some of the modern artists, Kandinsky or, things like that. And some people may say, well, I don't like that anyway. Well, that's okay. But what I'm basically saying, that's really what Rick Rubin's book is about. It's about the catalog of what's possible in the real estate of the human frontal lobes, because that's really what separates us from chimps. And melanin is what created that. And to understand how that story goes all the way back, to bacteria like you mentioned in a nuclear reactor that can do some things that we think are unfathomable.
Yeah.
No, I got news for you. There's a fractal geometry between that bacteria and what's going on between me and you right now. And to me, it's fascinating to actually think about that. And for other people who don't have that fascination, I guess those are the people that I don't want to spend a lot of time with or have a brandy with or sit down and have, coffee with. I find the people that I'm drawn to most are the people that are interested in finding out really how we work in nature.
Yeah, I think back to the thing about, first of all, anesthetics making us less conscious, and then wearing clothes creating creativity. I think the psychedelics people would have something to say there, because they'll say that psychedelics are sort of the seat of our evolution. And then I was going to ask whether psychedelics are consciousness enhancers or whether it's just a big red herring.
Sarah, did you said you read my last blog?
I haven't. No, I've half read it. I'm at the bit.
Right, but you saw Alexander Wunsch's slide that's in there about photo.
Oh yes, yeah. I've about
acids.
about chromophores. I've seen that lots of times.
But did you see the one path in there? I want you to look at it a little closer. You know what it says there?
Well, yeah.
Tryptamines.
Tryptamines. Yeah, that's really written very small. Yeah.
Small, but guess what? That's where they come from. So it's a melanin story. So even the drug addicts that like this work and think that's where the evolution came from, it's still a melanin story. And they don't know it.
But that's, yeah, I suppose the pineal gland makes the DMT, and then that's all. What's the pineal gland? Is it an antennae? But then it's just going to be full of melanin again. So, yeah.
It's going to be a story tied to this story. That's what I'm saying. It's kind of like the argument that I made for you earlier in this podcast about Peter Attia. The same reason I would get on Peter Attia is the same reason I would get on these guys that, want everybody to trip.
Yeah.
No, I think, in fact, I've said this, and if I haven't published it yet, you're going to see it in a coming blog, that the people that get a benefit from using mind-altering chemicals like DMT, psilocybin, all this stuff for mental disorders, that tells you have a melanin renovation problem in your head. That's fundamentally what it means. And, I've been around people that have taken those medications and they've not had any of the effects that people who use it, like when people go on these ayahuasca trips, like I've got a member who I'm thinking about right now who told me, I will pay for your trip. I want to have an ayahuasca trip with you, Jack. And I told him, I said, dude, I don't think it's going to do anything to me, because he did it. He happens to be a doctor. And I'm like, I don't think it's going to affect me, because I think my redox in my head's pretty good. My redox in other parts of my body may not be so good, but I don't think it's going to have a huge effect. And I told them, in my past, when I was a kid, I had the opportunity to do mushrooms with my friends. This when I was a teenager, did nothing to me. Absolutely nothing. And when I saw Alexander's slide and I saw that was there, I was hoping that people would begin to ask me the question you just asked me. Because this is another one of those aromatic amino acids that is being changed by this VUV light into things that allow us to do things we do. And do I believe, because you haven't asked this question, but I know it's probably circulating in your head, do I believe this is why psilocybin, ketamine, LSD, all those drugs can have effects for people that have dopamine problems in the frontal lobes? Absolutely. No question about it. Do I think it's one of the, I don't want to say solution, but I think, is it potential to help their symptoms? No question. Like you asked me a big question earlier about bipolar disorder. I never got into this. I did write blogs about it a long time ago, but I think people have forgotten about them. The reason why lithium works in bipolar disorder has to do with the isotopic fractionation between lithium-6 and lithium-7. That's the reason why. It's a nuclear effect. And there's a scientist named Miller who's working on this. In fact, Rick Rubin sent me a text after the podcast went live and asked me the same question that you just asked about bipolar disorder. He actually sent me a paper about lithium, and I didn't have the heart to send him back the paper that I was just telling you about the isotopic variation between lithium-6 and lithium-7. It turns out that lithium-6 and 7, it's not all the same isotope that has the good effect on bipolar disorder. One has a better effect than the other. And the reason why, this is a quantum nuclear effect tied to what's going on in the brain. And when you see this, the person I think in your probably world that would be interested in something like this, because I'm not sure he knows about it, is El Khalili. Why? Because as a nuclear physicist, to see that an isotope can have that big an effect on physiology, it's amazing. It's absolutely stunning when you see it, but it's the truth. And the thing is, it's it's blatantly obvious the reason why chloroplast and mitochondria are racist against deuterium. It's the reason why we have all those 9 enzymatic steps in the metabolism of glucose. Nature is trying to get rid of deuterium for us by design on certain parts of the carbon backbone that are used in all these biochemical pathways. When you see this perspective, when you see this facet, because I jump all over in this podcast, so many different areas of science, but when you start to see where the pieces fit, it's hard to become ignorant again.
Well, yeah, because deuterium's too big. It's going to, if you're trying to make energy, a great big thing like deuterium is going to get in the way of the energy production, and it'll break the ATPase because it's too big.
Yeah, well, that's the one that the guys that are trying to rob people in Los Angeles making deuterium depleted water will tell you.
Yeah.
I'm going to tell you the flip side is it goes back to E equals MC squared. Let's just go back there. Energy and mass are equivalent. Einstein said it, right? So what does that mean? When you add another neutron to a proton, what does that mean for mass? It means it totally screws up the energy. So it tells you that H plus, protium, is more thermodynamically efficient than deuterium. That's the real reason the matrix and the ATPase was innovated by nature to use H plus and not deuterium. That's the reason why remember, photosynthesis had to take the water in the hydrology cycle on this planet and create photosynthesis with it. Turns out when that water has high deuterium in it, the food that it creates also will have high deuterium in it. And the crop yields will be down. Okay? In other words, it's not pro-growth.
Like 40%.
What does a mitochondria do? It reverses that process. But we don't make water with deuterium. We make deuterium depleted water. So there is a difference in the mirror image of oxidative phosphorylation and what's going on with the ribisco enzyme. The difference is photosynthesis on Earth can take all forms of water and create food with it. But it turns out mitochondria only want to use food that's been made by photosynthesis to turn it into deuterium depleted water. And what does it do? The amount of water created from carbohydrates on a molar basis, because let's get this straight. You're supposed to be a PhD scientist, so I'm cutting straight to the chase here. What connects the reality level through thermodynamics to quantum? There's only one thing: Avogadro's number. Okay, Avogadro's number tells you how many atoms are in 1 mole of something. So just so we're talking science here, okay? How do I make this connection? When you eat carbohydrates, okay, equivalent molar issues will create 55% water in mitochondria. Proteins around 70-75%. Fats, 100. So what does that tell you? Eating saturated fats from animal products creates more water in a mitochondria that is deuterium depleted than eating carbohydrates. Why does that make fundamental sense? Because the hydrology cycle on Earth is totally tied to this. Deuterium is at its highest level at the equator. It's at its lowest level where you live, up in the poles. And it makes total sense why that would happen. When you have less light at the poles, you need less mass to run the thermodynamics. That's the reason why past the boreal forest, nothing uses photosynthesis. Nothing. The 59th to the 60th latitude is where photosynthesis gets extinguished. There's a lesson there for light people. There's a lesson there for deuterium people. There's a lesson there for physicists. Lots to think about.
Yeah, I was thinking about that today, about how at the equator there's more, the deuterium in the fruit is less of a problem. But then where I live, we've got less deuterium in the water, but then we've got less
problem for you.
Yeah,
eating bananas and fruit for you is even a problem on June 21st at the equinox. Yeah. It's a huge problem for you. You're absolutely correct.
We've got the cold, though. The cold is my friend here. That's the important thing that we UK people don't use properly. Because like you said, right back to the story, I can make light in the dark like the mammals underground did with the asteroid. So It's about thinking, well,
remember, wideband semiconductor allows you to make DUV light from cold. They function better in cold. That was the story that I wrote 15 years ago in CT6, the ancient pathway, the superhuman pathway, the Sherpa pathway. I actually just did a podcast about the Sherpa pathway 2 days ago. That it's not out yet, but when it comes out, that's going to be an ass kicker.
Mm-hmm. Yeah. Yeah, and there's one more thing. It's like just to tie it back all up together. And I'm sure I've heard you say this before, but when people have got a really good redox, and whether they use a Magnetico or not, their dreams get colorful again and more vivid. So it's back to this thing about the psychedelics, that if I improve my redox and I have psychedelic dreams, am I not curing myself in the same way that people take psychedelics exogenally?
I don't think so. I think what it's a remnant of is that you're now creating different frequencies of light from the VUV, UVC, UVB, and UVA spectrum inside. That's what it's a signal to me. Now, that is total speculation on my part, but no, I would not equivocate those two because
dreams are very healing, and as you get older, I ask my clients all the time about things like this, and the older ones say their dreams are less colorful and worse, and then I'm again really interested in dreams and quality, and I have noticed, and you brought it back up again about the redox potential and having better dreams.
I've always dreamed in color.
Yeah, with more melanin. That's why if you took psychedelics, it probably wouldn't have such an effect because, you're halfway sort of there anyway.
Well, I think my brain is.
Yeah.
I think my brain is. But remember, I'm 60 years old. So by Wallace's work, I'm working on my 7th decade. My heteroplasmy rate should be pretty high. I don't take any medicines, none, for nothing. And I sleep like anybody who's ever been around me. You can ask my members. I go to sleep in like this, and I sleep straight through. I sleep like a rock. The members that have come with me to El Salvador are like shocked. I'll go to bed at 8 o'clock and wake up with the sunrise the next day. And I've always slept really, really good. I just personally think that when people get a benefit from the psychedelics, it tells me that they got a big time melanin problem in their head. It's either that the melanin's not there, or the other big one that I think the biggest problem is melanin renovation. That's where the story gets important that I really didn't get into with the guys on the podcast. How we renovate melanin. That'll be coming down in my series down the pike. But I think most people who've been following me a long enough time probably know the answer. Get in the sun.
Oh, yeah, it will be.
UV light. Got to have UV light to do it.
Oh yeah, I really like UV lights, even lamps. But then I think it's sort of, again, I was going to ask you, with your dreams, are they really? Can you remember them? And are they kind of technicolor?
Don't tell. Can I remember my dreams? There you go. Yeah. I in fact, she actually hears me talking about things in the dream, and in the morning she wakes me up and says, "What were you saying to that person? Tell me about that discussion." Sometimes she's actually been with me where I'll wake up in the middle of the night and start having to write it because of what happened in the dream. Yeah, that's how vivid they are.
Yeah, I thought they would be, and I think there's it's back to the temporal lobe epilepsy. It's like a superpower, harnessing your dreams, but you need to have a good redox to enable to have dreams like yours. So it's again another sort of thing I've been thinking about that I've not been able to put the pieces together properly, but I think what you've just said has really homed it in for me again, that it's back to, who are you? Are you daytime Jack or nighttime Jack?
No, it's true. I mean, and right now you got low voltage Jack. Well, technically you don't. I just came off trauma call for 3 straight weeks, so I got my ass handed to me. But I'm right now at the 28th latitude. I have been outside for, today's Friday. I have been outside for 5 straight days, sitting right where you see me. Like Chantel's in the sun over there. The weather here, I mean, right now it's probably 85, 87 Fahrenheit. Sun's been out. I got pretty good tan for a guy who's clayed comes from the 59th latitude.
Yeah.
And I'm looking at you in here and I'm going, God, it's May 5th. And Sarah, you look awfully white to me. You need a trip. You need a trip to the Canary Islands.
Oh no, I'm just building. I do go. I am just building my melanin coat because I had a few grey hairs and they've kind of gone. So
I got plenty of those. I got plenty of those.
Yeah.
I got plenty of those. But like I said, I think that when you do my job, and trust me, I know that I'm trading time for money doing this. But at the same time, I also know that the next step for me is going to be moving, the way I look at it, my whole life, my heteroplasmy that I came out of my mother with was 59th latitude. I grew up at the 44th latitude. Then I relocated, came down for a short period of time to get my degrees at the 28th latitude, then went back up to about 35, realized 35 was a problem. Now I'm at 28. I'm doing okay, but I know that in order to do trauma call, I need further south. That's El Salvador. I need 13. And I think I can die at the 13th. I think I'll be okay. I'll live out my longevity down there. As I said to Chantal earlier today, I said, I can envision myself listening to science talks of centralized guys and figuring out what their problems and miscommunication are and just do podcasts like this and tell people no. Because I think someday down the road, podcasts like this are going to be important for people to hear when I'm dead.
Mm-hmm.
And they realize, because I often think about when Einstein died, what would I ask Einstein, today and how he thought? And it actually caused me to buy a book when I was younger. I felt the same way about Da Vinci. Then I found out there was a guy that wrote a book about how Da Vinci thinks. And I said, when I walk around the Louvre or I walk around Italy and I see some of Da Vinci's work, I said, I can gain some insight about light, water, and magnetism if I understand how he thinks. And the thing that I guess I got from them the most is actually how to embrace paradox.
Mm.
I think you can be, as a scientist, I think you'll have to try this on. Instead of you doing mushrooms and psilocybin and all that stuff, I would like some of these people to go to Hyde Park, sit in the sun for an hour or two, then go into a museum just for maybe an hour and look at some of the best artwork that the UK has. I think you'll begin to notice things happen in your brain that are probably more profound than when you trip. Maybe I'm wrong. It's hard for me to say because I've never had the experience of tripping, but I hear all these people talk about, how wonderful it is. And I have to be honest with you, Sarah, I get more excited talking about what we've talked about today than me doing an ayahuasca bender. I mean, I'm being honest with you. I just, there's no drive in me. There's no dopamine level in me that makes me want to do that. I look at my brain as my companion that allows me to navigate, the pathways of human history, evolution history on this planet, to contemplate what happened 3.8 billion years ago with the Big Bang, and to think about the transition between chimp to human, and think about why Darwin was wrong about the Cambrian explosion. To me, that gets me horny. I love that shit. I just have no drive to sit down and trip with a bunch of people.
I think you should always trip on your own, because if you want to do it with other people, it shows you're not ready. But then I thought DMT was brilliant, and I thought, well, that was fascinating, but it's not relevant to the rest of my life. And I'm the same as you. I'm more excited about magneticos and understanding in detail what Dr. Dean didn't have a chance to further his research with, and just all sorts of other things. There's, no matter what, there's always more that I don't. It's like you say, that I think is the phrase, the deeper, the further I swim away from the shore, that the deeper the ocean. And that's how I am with knowledge. And it's like I just continue to unearth stuff, and then it comes to a point I've got no one to talk to about it, and I get really cross at other people that just tell me the sun's dangerous, or I don't know.
Yeah, but guess what? They did you a favor, Sarah. The
Yeah.
people that tell the sun is dangerous, those are the people you shouldn't have brandy with.
Yeah.
I'm being honest with you. You got to collect misfits.
Yeah.
And I can tell you this experience that I've just gone through with Rick. Rick being not only my friend, but also being my patient, and him coming out of his shell to say what he said and to put me next to a guy who I had a huge problem with. And Rick saying, he goes, look, this is exactly what I do in the music studio. I take something that isn't finished and I try to finish it. Because, and I'm trying to do that with you. He goes, you have a lot to offer. And I think the fastest way for you to offer it is to a guy like Huberman, who is going to infect all these kids. To be honest with you, Rick's idea was brilliant. I didn't act on it. If it wasn't for Chantel, I wouldn't have never went to do this. And she said the same thing to me. She said, do you realize what's gone on in science the last 2 or 3 years with COVID and how centralized science has corrupted everything in the world? She goes, this is your opportunity to actually go and tell people how mitochondrial medicine has been buried because of the paradigm of Darwin, the paradigm of Dawkins. Like, everybody wants us to focus in on nuclear genes when it turns out it's the mitochondrial genes that interact with the nuclear genes. That's what POMC is. POMC is a nuclear gene that only gets translated with UV light. It's crazy when you think about it. And I have to tell you, when she said it to me, she's one of the few people that I will actually sit down and listen to. And she said it to me, and I was pretty quiet for about an hour, and I thought about it. And it wasn't an easy decision for me. You heard in the podcast, Rick say, yeah, I contacted Jack. It took him 6 weeks to answer him. And that's the truth. It took me a while to think about doing it. And right now, I'm not doing, podcasts for everybody. I want my people to save their money, put it in decentralized things so that they can move to environments that will stimulate POMC. The things that you and I talked about today, I told you what my key to longevity is. My key to longevity is making sure we optimize POMC biology, melanin biology. How could I get behind somebody who's given an incongruent message? They may not be saying it face to face, like through the podcast, but the actions dictate it. And that's part of the reason why I always go back to my band TED Talk, that people have found that ideation without execution leads to deletion of every good idea. The problem is, if you get a good idea, but you execute on it, for profit, doesn't that make you just like Big Pharma? Like, what? You can't talk shit about Big Pharma then. Like, there's a reason my Patreon blogs are only $5 a month. If you don't think that some of the stuff you and I talked about today is worth the price of a cup of coffee, then I'm sorry. This is about as close as you're going to get to getting something for nothing. And I fundamentally believe when you get something for nothing, you usually don't value it. The reason why it's $5, it's because I want everybody to know this message. But at the same time, I know that if you didn't pay the $5 a month, you're not going to read all 40 blogs in the quantum engineering theory. And you're certainly not going to read the 500 other blogs that I've written.
Yeah, because people just want the quick answer. And I think for me, my key to longevity is I'm just freezing all the time. And that's one thing I agree with David Sinclair about, is humans are meant to be cold. And the light thing, I'll have to solve that problem soon. But as you say, I think it's just reiterating and punching people in the face about how important the sun is. And it sounds
remember what you're experiencing, though. You're going to do a good job with your melanin sheets inside your skull. The point that I'm trying to make to you, like, this is like, if you're really interested in longevity, you're interested in Aubrey de Grey and Adia and even Sinclair. What I'm telling you is, a woman. I don't know how old you are. I don't know anything about you. I mean, it's the first time I've ever really interacted with you. what I'm trying to tell you is that I've already said to you, you're pale on the outside. Realize when you get to a low latitude and you start developing your melanocytes from POMC that's in your skin, girlfriend, you're gonna get a lot better. You're gonna do really good. I mean, I've got a really good friend. I don't know if you know her. Her name is Sarah Hodgkins.
Yes, we connected. She lives quite close to me. She's an EMF surveyor.
Wow. So guess what? Let me just tell you about her.
Yeah.
When I got her to come to Mexico and spend time with me, her electrohypersensitivity went completely away. And I was very proactive and provocative with her, just like I'm trying to be with you. If you really are interested in this longevity thing, you have a duty to yourself to come down to low latitude environment for 5, 6, 7 months and come see if Uncle Jack's wrong. You may be shocked because remember something. You understand this POMC story. Your skin is a solar panel for your brain. I totally agree with you that you staying at the 52nd latitude, you're going to make VUV light and your melanin sheets on the inside can be fine. I'm telling you, they can be a lot better when you turn that surface into a melanin sheet that augments what you already have on the inside. That's when Sarah Pugh becomes a little Sherpa from London.
Mm. Yeah, so that's the key to that's my next thing. I have got my eye on El Salvador, and I think what you've just said about helping people to earn enough money to be able to move, because I had a client yesterday with MS, and I'm not going to go into it, but you can guess that she was doing everything with her diet and her supplements, and then her light stuff was horrific. And I lent her one of my red light panels, and I just was thinking, that lady's never going to get better until she moves.
It's true. And that's the sad part, that when you tell somebody the truth and they look at it as a non-answer, that that you can't help that person. It's actually easier for me to move away from that if they don't understand, because I have I think my profile picture on my own forum says I'm not in this to be everybody's to be liked by everybody. I just want to be your wake-up call. That's it. That's all I'm interested in. I mean, I don't want any patient to ever come to me and say, Jack, you never told me the truth. They may not be able to make the truth happen in their own life, but I'm not going to lie to them and tell them that taking metformin or using melatonin on their skin or some MLM marketing scheme is the way to go. That's bullshit. It's total bullshit. I want you to know the truth. I want to change medicine. That's my goal.
Well, the thing is, because biologists have messed up everything to do with water science, that's another humongous problem, that everything to do with water in the textbooks is wrong.
Well, I don't know if they've ruined everything. I think a lot of the water science has been righted since 1993 from Will T. Robinson. In fact, I mentioned that to Uberman, that his university actually confirmed that water does have 2 states. That was huge. And then you have Paparda and Gelduse, both physicists who were nuclear physicists like El Khalili. I don't even know if El Khalili knows about their work, but guess what? Their work was huge, and it vindicated one of your countrymen, Martin Chaplin. He's a great water researcher in the UK. Very few people know about him. I do. I mean, these are the guys that they taught me about water when I didn't know anything about water. And then to see like May Wan Ho, who's also dead, also a UK, scientist. These people are all important. Everybody's got their role to play. I think my role is just as an innovator to take all the different parts of the 3-legged stool and explain it to people how the pieces fit. That's why I like Tool. I see where the pieces fit because I know where they fall apart as a neurosurgeon. I see people falling apart every day in my clinic. It's almost like a giant laboratory experiment. Instead of having to use rats and mice, I get humans.
Yes, there's a lot to think about from this, but yeah.
All right, Sarah. It's going to be time for me to go because I got to get moving here.
Yeah, I've got to see the sunset. I just
There you
get
go.
to rush out. And yeah, thank you so much for your time. I really appreciate it. And it's been really, really a pleasure to meet you. And
No problem. Anytime. And when you get ready to send this off, send me the URL and I'll share it for you on social media.
yeah, okay, great. Thank you.
All right.
Okay.
All right. Take care.
Thank you. Bye, Jack.
Bye-bye.